Hi, my name is Sienna, and this is my lovely model, Karen. Yay, thank you for volunteering. And today we're going to be talking about baroreceptors in the control of blood pressure. The cardiovascular centers detect changes in tissue demanded by monitoring blood pressure specifically for baroreceptors. For chemoreceptors, it would be different, but we are not talking about that. The baroreceptors respond to change in blood pressure by monitoring the degree of stretching that occurs in the aortic sinuses and the carotid sinuses. The aortic sinuses are shown here with the blue yarn, and the pink are our carotid sinuses. Sorry, I'm sick. These receptors are part of the baroreceptor reflex, which adjusts cardiac output and total peripheral resistance. Cardiac output is just the amount of blood ejected by a single ventricle per minute and is calculated by stroke volume times heart rate. And peripheral resistance is determined by vascular resistance, blood viscosity, and turbulence, which we've all talked about before. When blood pressure is increased, the stretching sends the message to those baroreceptors, hey, I'm being stretched, and then the basal rate of action potential is increased. This action potential, is generated in the glossopharyngeal and vagus nerves, in the cardioregulatory and vasomotor centers in the medulla oblongata. Since blood pressure is increased and baroreceptors are like sending that message and increasing the action potential, the cardioregulatory center increases the parasympathetic stimulation to the heart, and it creates a cardioinhibitory response, which just means that the right and left vagus nerves secrete acetylcholine, which bind to muscarinic receptors, to nodal cells, which then hyperpolarize and then slow heart rate and decrease stroke volume. Stroke volume is determined by preload, afterload, and the contractility. Now, if the opposite were to happen, if blood pressure were to decrease, the same process would occur, but instead of the cardioinhibitory response, it would be the cardioacceleratory response, which means that it would be a sympathetic response, and that neuron epinephrine would be released, which would then bind to beta-1 receptors, which would increase heart rate and increase volume. Round of applause for Karen, and I'm out.